You know, the biggest revolution in human history is happening right now, all around us. But here's the catch. You can't see it. Not a single bit of it. It's not happening in some giant factory. It's happening at a scale so incredibly small it's almost impossible to comprehend, building our world, one atom at a time.
Just think about that device that's probably in your hand or in your pocket right now, your smartphone. The chip inside, the very brain of it, it's basically an entire city of circuits, built on a scale that is just mind-bendingly tiny.
Or how about the jacket in your closet? The one that keeps you warm but isn't bulky at all. Or the one that sheds rain but still breathes. That's not magic. That's scientists literally rewriting the rules of what a material can be.
And this goes way beyond the things we own today. We're talking about the medicine that's going to cure diseases we thought were incurable, the energy sources that'll power our world. This invisible tech is the bedrock of everything that comes next.
So what is it? What's the secret ingredient connecting all of these incredible things? Well, it's nanotechnology. And in this explainer, we're going to pull back the curtain and make the invisible visible.
So let's start with the ghost in the machine. Because look, this isn't science fiction set 100 years from now. Nanotechnology is already all around you, woven into the fabric of your daily life, often in places you would never, ever expect.
Remember old school sunscreen? That thick, gloopy white paste that made you look like a ghost at the beach? Yeah, that was just zinc oxide. Well, today, they take that same mineral and grind it down into nanoparticles. They're so small they become completely transparent, but they're still absolute champs at absorbing UV rays. Same protection, no white streaks. That's your everyday nano upgrade right there.
But it gets even cooler when our clothes start becoming, well, active. Take something like Uniqlo's heat tech. Here's how it works. Your body is always giving off tiny amounts of water vapor. Special rayon nanofibers in the fabric are designed to suck up that moisture. When they do, a chemical reaction converts the kinetic energy from those water molecules into heat. It's literally generating warmth from your body's own moisture. Then, tiny air pockets in the fabric trap that heat. Your shirt is actively working to keep you warm.
And in the world of sports, oh man, nanotech is just shattering records. All that controversy around Nike's Vaporfly shoes, it's not just the carbon plate, it's the foam. A special polymer engineered with a unique nanostructure that gives back a ridiculous amount of energy with every single footstep. It makes runners about 4% more efficient, which is so huge that even Usain Bolt called it technological doping. That's right, he put it in the same league as steroids.
And then there's this number, 50 billion. That is how many transistors IBM has managed to cram onto a chip the size of your fingernail. This isn't just some lab curiosity. This is the tech that's going to power our future phones, maybe letting them last 4 days on a single charge. It's all thanks to this relentless race to get smaller and smaller. It's pure nanotechnology.
Okay, so we've seen what it can do. But the real question is, why? Why does shrinking something down to this invisible scale give it these incredible superpowers? To get that, we have to zoom out from the products and zoom in on the fundamental physics of this tiny, tiny world.
We're talking about the nanoscale. Officially, that's the world between 1 and 100 nanometers, and this is where things get really weird. It's not just a smaller version of our world. Down here, the normal rules of physics, the stuff Newton taught us, they start to break down, and the strange, almost magical rules of quantum mechanics take over.
To really wrap your head around how small this is, check out this analogy. Let's say 1 nanometer is the size of a single marble, okay? On that scale, one of those IBM transistors would be just 2 marbles sitting next to each other. A virus? About the size of a soccer ball. A single human hair would be as wide as a giant redwood tree. And a tennis ball? A tennis ball would be the size of planet Earth. We are operating on a scale that is just truly difficult to imagine. So all this smallness creates 2 main superpowers. First, you get what's called surface area dominance. When a particle is tiny, a huge percentage of its atoms are on the outside surface, which makes it super-duper reactive. It's perfect for things like catalysts. The second one is quantum confinement. When you trap electrons in a space this small, you totally change how the material interacts with light and electricity. This is exactly how the quantum dots in your QLED TV work. A tiny dot of material, just 2 nanometers across, glows blue. Make it a little bigger, say 6 nanometers, and it glows red. You're literally tuning the color of light just by changing the size.
Now, this amazing ability to just rewrite the rules of matter, it's not just for making brighter TVs or faster shoes. It's being aimed at solving some of the biggest, toughest challenges humanity has ever faced. Everything from deadly diseases to cleaning up our planet.
Let's talk medicine.
Traditional chemotherapy. It's like carpet bombing an entire city just to hit one single building. The collateral damage to the rest of the body is just immense. Nanomedicine, on the other hand, is like a smart sniper. See, tumors grow so fast that the blood vessels they create are leaky and full of tiny gaps. So scientists can design nanoparticles that are too big to leak out of your healthy blood vessels, but just the right size to slip through those gaps in the tumor. They build up right at the cancer site and deliver their poison exactly where it needs to go, leaving healthy cells alone.
And this isn't a someday technology. It's saving lives right now. A drug called Onivide wraps chemo for pancreatic cancer inside a tiny bubble of fat, a liposome, that helps it target the tumor. And hey, we all got a crash course in nanotechnology with the COVID-19 vaccines. It was lipid nanoparticles that acted as the delivery vehicle, protecting the fragile mRNA and getting it safely into our cells. And the next frontier? They're designing nanoparticles that can basically trick the brain's super tight security system, the blood-brain barrier, to finally get drugs in to treat diseases like Alzheimer's and Parkinson's.
What about the environment? This is so clever. Scientists have made these tiny magnetic carbon nanocoils. You just release them into water that's full of microplastics, they spark a chemical reaction that just breaks the plastics down into harmless CO2 and water. And here's the best part. Because they're magnetic, you just use a giant magnet to pull them all back out of the water so you can use them again. It's such an elegant solution to a huge, messy problem.
So once you have these kinds of incredible, foundational tools, concepts that used to be pure science fiction are suddenly becoming, well, they're becoming serious engineering challenges. We are literally building the world of tomorrow today.
I mean, come on, the space elevator. This is the classic sci-fi dream. A cable stretching 36,000 kilometers from the ground all the way to orbit. For decades, it was completely impossible. Any material we knew of would just snap under its own weight. But then, we discovered carbon nanotubes. These are sheets of carbon, just one atom thick, rolled up into a tube, and their strength-to-weight ratio is just off the charts. Now, we can't make a perfect cable that long yet, but the material exists. The fundamental physics barrier has been broken. The conversation is totally shifted from if to how.
But, and with a technology this powerful, there's always a but. We have to talk about the flip side. For every incredible promise, there's a potential peril. We have to be smart about how we navigate this new frontier, and we have to do it with our eyes wide open.
The risks are very real, and they kind of fall into three main buckets. First, there's toxicity. The very things that make nanoparticles so useful, their tiny size, their high reactivity, could also make them dangerous if they get inside our bodies. Second, surveillance. Think about smart dust, billions of microscopic sensors floating around, monitoring everything, creating a surveillance network you can't even see. And third, and this might be the biggest one, inequality. What happens when nano enhancements that could make you smarter or live longer are only available to the super rich? We could create a permanent biological gap between the haves and the have-nots.
Now, you might have heard of the ultimate sci-fi nightmare, the gray goo scenario, where self-replicating nanobots just eat the world. The good news is, most scientists think that's highly improbable. No, the real threats are much more subtle and much more realistic. Things like industrial accidents releasing nanopollutants, or someone using this tech on purpose for control or for warfare.
And listen, these aren't some distant future problems. The debates are happening right now. The European Union has already banned the nanoparticle form of titanium dioxide as a food additive because of safety concerns. We're seeing that some gene therapies, which are a form of nanomedicine, can carry a risk of causing other cancers down the line. And like we talked about, sports authorities are already trying to figure out what to do about technological doping. We're in brand new territory here, and we need a whole new social contract to figure it all out.
So this all leads to the ultimate question. As we gain this godlike power to design our world, literally atom by atom, what kind of world are we going to build? Will we use this power to create a healthier, more sustainable, more equitable future for every single person? Or are we in danger of engineering the ultimate biological divide? The technology is here. The choice is ours.